Сьогодні вже другий день нашої LvivPy нових 10. Сьогодні буде теж 3 доповіді і спробуємо зробити цього разу лайтінг токи. Десь приблизно після першої або після другої доповіді я поширю документи, куди можна буде зареєструватися на Lightning Talk. Для тих, хто не знає, що таке Lightning Talk. Lightning Talk – це дуже швидка доповідь на 5 хвилин. Слайдами, без слайдів презентувати можна майже будь-яку тему. Після того, як зареєструєтесь, знайдіть мене в Телеграмі. Я там є в каналчику нашому. Хто ще не приєднався до нашого телеграм-каналу, там тихо і ніхто не спамить, і взагалі ніхто не розмовляє. Ось QR-код, скануйте, приєднуйтесь. І після третьої доповіді будемо проводити лайтінг токи. Подивимося, скільки не збирається людей. Першим доповідачем буде Віталій Кучерявий. Неочікувана доповідь про Django. Вже давно нічого не чули про це. Тому Віталій, давай.
Okay. Так, алло, как слышно? Привет.
Привет.
Так, надеюсь, получится. Я сейчас немножко далеко от цивилизации, но все-таки кое-какой коннекшн есть. Так что, может, хотя бы по видео и по слайдам все будет понятно, если все-таки мой голос будет пропадать. Значит, сегодня я покажу проект, который называется Django Ninja. Это такой Fast Django REST Framework. То есть это еще один REST Framework, но он очень хороший, очень быстрый и, наверное, будет самым лучшим. Немного обо мне. Я очень долго занимаюсь питоном, наверное, уже больше 12 лет. Очень много я работаю с API-ами, то есть я либо даю кому-то какие-то API, либо читаю какие-то API, интегрирую с какими-то компаниями, приложениями, впрочем, то есть, не знаю, за всю жизнь, наверное, API интеграции было так много, что, не знаю, если бы мне по $1000 за каждый API платили, я бы, наверное, был бы уже миллионером. В общем, то, что я наблюдаю в последнее время, это то, что OpenAPI, он начинает, наверное, все-таки немножко побеждать. То есть, если кто не в курсе, что такое OpenAPI, это бывший Swagger, то есть это такая спецификация на YAML либо на J, которая описывает полностью, как работает ваш API, и, соответственно, клиент может быстро сгенерировать себе клиента, просто прочитав этот JSON и сгенерировав какой-то код, либо создав какие-то вызовы динамические. Как вообще в мире по API, ну, как бы, если брать самый популярный Flask и Django REST Framework, они появились намного раньше, чем появился тот же Swagger, тоже OpenAPI, и поэтому как бы в плане интеграции зачастую всегда нужно делать какие-то дополнительные шаги, какие-то дополнительные телодвижения, что как бы, да, вот у нас есть там, например, DRF какой-то API, и чтобы к нему прикрутить OpenAPI схему, нужно, да, проделать там, то ли установить там какой-то дополнительный фреймворк, как-то описать, то есть, ну, как бы жизнь, как бы, ну, не совсем, как бы, приятная и идеальная, я бы это укоротил. Это все связано с тем, что, как бы, вначале все-таки появились сами фреймворки, а потом, как бы, появился OpenAPI и вся вот эта вот REST-тенденция. И, собственно, где-то, может, полгода назад я попробовал Fast API, то есть, как бы, то, что Fast API сделано, то, что вся структура фреймворка построена на том, что с помощью типизации мы можем просто описать в коде их декораторы и на выходе получить уже готовую OpenAPI спецификацию со всеми параметрами, со всей валидацией. То есть, грубо говоря, да, вот мы тут описали, что у нас там item ID это in, не нужно вообще никакой делать никаких телодвижений, чтобы делать какую-то валидацию, либо описать это какими-то XML, JSON, что это именно тип int и как его нужно валидировать. Жизнь такая, что как бы Fast API декларирует такую, можно сказать, фреймворк-агонистик подход, то есть можно брать любой фреймворк, можно брать любой ORM, все что угодно, но в итоге, как бы, если мы берем Django, как бы коннектимся к ORM, делаем какие-то API операции, в итоге получается не все так уж и радужно, потому что как бы все равно нам нужно делать какие-то дополнительные телодвижения, чтобы описать этот, конвертировать, да, Django query set, какие-то списки в Fast API, и как бы сам подход, то, что как бы Fast API построен на базе Starlet и с такой вот асинхронной природой, в то же время Django еще как бы полностью не готов к этой синхронной природе, и иногда получается так, что, например, если пул соединений создать, ну, Django создает пул соединений в thread locals, да, и этот thread locals может создаться, например, Fast API в Starlet в одном каком-то потоке, потом не закрыться в другом, и в итоге нам приходится делать какие-то дополнительные костыли и какие-то дополнительные функции, которые бы все это обвязывали, не давали бы всему этому упасть. В общем, покрутив это все, попробовал, я решил все-таки отказаться и попробовать все-таки сделать какой-то свой похожий подход, просто взяв Django, взяв PyDentic, где-то в итоге, наверное, написал около, не знаю, там, может, 500 строк кода. В итоге получился довольно-таки рабочий вариант, который, в принципе, даже по какой-то случайности оказался довольно-таки производительным. Да? То есть если мы берем в однопоточном режиме, мы просто валидируем какие-то более-менее крупные объекты, да, то есть делаем JSON-валидацию и JSON-сериализацию, то в итоге Django Ninja вполне себе выигрывает где-то процентов на 5 у Flask с Marshmallow и, наверное, раза в два быстрее получается скорость валидации и сериализации по сравнению с Django REST фреймворком. И картина получается совсем другая, когда мы используем асинхронный вызов, да, если у нас есть какой-то, не знаю, удаленный какой-то, может, network call, которого нужно ожидать там какое-то небольшое время, и в итоге просто с двумя воркерами на Django Ninja можно с головой покрыть то же количество воркеров, которые нам нужно создать в том же USGI в Flask либо в Django. Собственно, основные как бы фичи его это то, что весь API построен на базе питоновских тайп-аннотаций, которые автоматически конвертируются в OpenAPI и JSON-схему. И это же дает возможность сразу же делать автоматическую документацию, UI для тестирования, и сразу идет поддержка асинхронных views, асинхронных операций и более глубокая интеграция Django, в частности, с джанговским ORM. И давайте я покажу как это работает. То есть, чтобы установить, достаточно делать pip install Django Ninja. Затем в любом модуле мы берем и импортируем Ninja API класс и создаем один API объект. И чтобы создать какую-то операцию, нам нужно сделать декоратор API get, например, от пути hello, то есть это диктует то, что мы будем создавать операцию hello от пути flash hello. То есть как бы get у API есть пачка методов, да, это все это get, post, put, и в итоге импортировать этот API-объект и добавить его в URLs. То есть мы импортируем, добавляем в URLs. Давайте я подсвечу. И, в принципе, все. Теперь достаточно зайти на /API/docs, и у нас будет всего нашего API, просто да, одним описанием вот такой вот функции с одним декоратором. То есть каждый метод каждую операцию можно описать ее HTTP методом, который вот конвертируется в OpenAPI спеку и генерирует сразу готовые UI для его же, либо если нужно передать кому-то эту документацию, вот готовый вариант, чтобы ее использовать. Передавать параметры. То есть мы в нашем операции hello мы просто передаем message. В принципе, можно не указывать никакие типы, то есть по умолчанию тогда это будет строка. Как видим, у нас теперь есть query параметр message типа строка. Так, давайте ее вызовем, и вот у нас на выходе получается ответ. Но если мы начнем указывать типы, тут все становится намного интереснее, потому что, например, в этом случае указываем, что message у нас будет типа int, и на всякий случай тут же мы его тут же выведем, какой, собственно, нам тип. В Swagger нам тоже подсветит, что это у нас уже теперь integer, и нам даже UI не даст ввести ничего. И в итоге при вызове у нас произойдет автоматическая валидация и конвертация в класс типа int. А если же мы вызовем, например, со строкой, да, с невалидным значением, то у нас автоматически мы получим 422, и то, что value is not a valid integer. То есть все, что нам нужно было сделать, это просто прописать, и в итоге у нас готовая сериализация, валидация и детализация по ошибкам. Также можно использовать path параметры. Это те, которые идут в адресной строке. Да? То есть у нас тут message теперь будет передаваться как часть URL. И, в принципе, все также происходит. И теперь у нас этот message параметр, он уже ожидается из path, а не из get. Наверное, интереснее все-таки поработать с базой. То есть создадим, наверное, какое-то небольшое to-do приложение. То есть у нас будет task модель, у которой будет title, boolean completed либо не completed, owner, foreign key на юзере и дата создания. Собственно, как нам, наверное, начнем с того, что как task, да, это у нас будет какой-то post запрос на /tasks, и что-то нам нужно передать, чтобы все-таки сериализировать и свалидировать входящие данные. То есть что мы делаем? Мы из Индии импортируем класс схему и создаем новый класс наследник от этой схемы, у которого будет title и, например, is completed. Да, это то, что нам приходит на вход. И прописываем как аргумент нашей createTask операции. У нас будет payload типа taskIn. Да, то есть мы ожидаем, что нам придет какой-то JSON, title типа строки и is completed типа boolean. И автоматически что это нам дает? То, что ваша IDE, она как бы будет понимать, да, что у нас payload это тип task taskIn. И значит, когда мы начинаем набирать, да, мы набираем точка, title, оно сразу подсказывает все атрибуты этого класса. И понимая также, что это title у нас, например, типа строки, может подсказывать все как бы дочерние методы и атрибуты, которые у нас есть, и в то же время подсвечивать нам, если мы что-то неправильно вводим, да, как неправильно складываем неправильные типы и такого рода ошибки. То есть такой подход, в принципе, все, что мы делаем, мы описываем входящий класс, и в итоге мы не только имеем валидацию на уровне HTTP, но и также валидацию линтерами, ID и прочими тулзами, которые помогут нам выявить ошибки, если мы, не знаю, сделали опечатку, либо неправильную работу с типами. Собственно, финал выглядит так, что, да, нам уходит task in, и мы создаем task с тайтлом и с completed теми данными, которые нам пришли по HTTP и сериализовались. Теперь, наверное, пример, как получить task. Да, это у нас будет get операция, в пути у нас передастся ID, ID у нас будет типа int, и все, что мы делаем, получаем из базы это task и вводим вот таким вот диктом, который автоматически сконвертируется далее в JSON и отдастся юзеру. Но вот эта вот часть, она довольно-таки, как видите, такая вербозная, да, то есть многословная, как бы хотелось, наверное, это все немножко упростить. И для этого можно использовать ту же схему, то есть мы описываем ответ, да, то есть мы создаем, что у нас ответ будет вот такого типа task out, у которого будет ID типа int, title типа строки, boolean completed и owner ID типа int. И все, что нужно сделать, это в аргументе get сказать, что response у нас будет типа task out. И все, что нужно сделать в самой функции, это просто вернуть этот task, и он будет автоматически сконвертирован вот этот объект, возьмутся только эти поля и дополнительно сконвертируются в эти типы и отдастся это все наружу. И причем не только отдастся, но еще произойдет дополнительная валидация, то, что мы передаем туда только то, что надо. Вот, например, в этом случае у таска у нас owner не обязательный, и поэтому нужно также прописать, что owner ID у нас типа int, но по умолчанию он может быть non, и это даст такой хинт, что это поле не обязательно и может быть пропущено валидатором. В итоге при вызове у нас будет вот такой вот ответ. В принципе, то, что мы описали, то, что мы... Потому что, например, у таска у нас было дополнительное поле created, да, вот оно, например, сюда уже и не вывелось, да, у нас только 4 поля, а created мы опустили. Также можно делать вложенные схемы. Например, создадим схему для юзера, у которой будет только ID, только first name и last name. И owner у нас будет этого типа user-схема. И, соответственно, owner у нас foreign key на юзер, у которого также намного больше полей, например, в том числе и пароль, и другие статусы. Но мы заинтересованы только в ID-шнике, first name и last name. И в итоге после вызова вот, объекта, у которого есть owner, нам также внутрь owner создался вложенный такой JSON-подобъект с данными, которые вот относятся к этому owner. Далее вот что делать со списками, да, вот, если нам нужно, можно ли сделать так, да, вот мы, чтобы получить список тасков, да, вот вернуть бы нам просто query set и все, да, ну, так на самом деле не работает, а нужно добавить еще описание response, то есть мы описываем, что response у нас будет списком из task out схемы. И в этом случае вот эта вот конструкция уже сработает так, как нужно, и нам на вывод будет передан уже заваливающийся query set, и на вывод пойдет список из task out объектов. Вот, собственно, например, мы вызываем все списки и получаем все таски. Например, у нас также происходит раскрытие, да, если есть owner, он уже раскрывается в более детальный вложенный объект. Как же, собственно, с асинхронщиной? В принципе, все очень просто. То есть, чтобы сделать вашу операцию асинхронной, нужно просто добавить keyword async, и все. Да? И причем, как можно заметить, то есть, например, здесь у нас одна операция не асинхронная, вторая асинхронная, что, в принципе, позволяет миксовать ваше приложение как асинхронные, так и асинхронные вызовы, что, например, даст возможность в каком-то коде работать синхронно, а в каком-то вызывать какие-то удаленные сетевые объекты и использовать как бы всю мощность асинхронной природы ожиданий. Но на самом деле так не сработает, потому что если вы вернете в асинхронном коле query set, у вас будет exception, что такой ошибка synchronous only operation. То есть как бы на данный момент с версии 3.1 Django есть поддержка асинхронных views, но еще нет поддержки асинхронного ORM. Но как бы есть workaround для этого, то есть все, что нам нужно сделать, это импортировать такой вот адаптер sync to async, взять наш query set и сделать его evaluation с помощью листа. То есть у нас в асинхронном режиме будет вызван query set, сконвертируется в лист, что как бы повлечет за собой вызов SQL запроса, и мы можем вернуть эти таски и в итоге получить то, что мы хотели.
Віталік, тебе задисконектило. Я зараз тебе повернемо. Да, ти замічений, до речі. Ні, тебе не чутно.
Так, а на каком слайде была последняя?
Там, где sync to async.
Sync to async, ага. В общем, просто будет достаточно, да, если
Да,
у нас
у
таска есть также какие-то вложенные объекты, и мы в этом случае тоже получим sync only operation, потому что их вызов произойдет уже после вот этого конвертации в лист. То есть для таких случаев нужно все-таки делать select related, чтобы этот вызов произошел фактически.
Тебе снова дисконектнуло.
Так, странно.
Да, і пошарь екран, бо слайдів не видно. Спробуй вимкнути камеру, може трішки дасть.
Окей, так, стоп, видео. Так, есть, да, экран есть, камеры нет, да?
Да.
Окей. Так, наверное, все-таки еще раз повторю. То есть, чтобы вот это все правильно асинхронно сработало, нужно все-таки, чтобы ваш SQL-запрос произошел в одном вызове. То есть в этом случае произойдет join owner, и у нас вот эта вот вся операция выполнится внутри одного await, и мы в итоге получим то, что хотели. Так, то есть проблема в чем? Как бы сейчас в версии последней Django 3.1 у нас завезли только асинхронные views, асинхронный ORM еще как бы нет. То есть нужно пользоваться пока sync to async адаптером. А в версии 3.2, которая, по идее, запланирована на следующий уже год, вроде бы подвезут и асинхронный ORM в том числе, и, возможно, нам в итоге можно будет пользоваться вот какой-то вот такой вот обычным query set результатом, и может все это будет дальше работать. Что еще есть? Еще есть версионирование в API, то есть мы можем создать несколько таких API, Ninja API объектов, каждый со своей версией, каждый со своими методами, может, какими-то повторяющимися, пересекающимися, деприкейтедами, и просто их описывать в пас как в версии 1, версия 2, и тем самым иметь в одном Django проекте несколько версий API, одного и того же API. Также можно иметь, например, какой-то публичный API, который может будет авторизоваться по токену, и может какой-то внутренний для админки, который будет, например, авторизоваться по session cookies. Значит, чтобы запускать все это дело в продакшене вам нужен какой-то ASGI сервер, например, Daphne или UVcorn. То есть вот, например, пример, как с помощью UVcorn запустить Django приложение, готовое с поддержкой асинхронных views. И как бы про планы, про roadmap, как бы сейчас этот проект крутится уже, в принципе, в паре боевых продакшн проектах, и то, что на данный момент реализовано, это как бы поддержка OpenAPI, асинхронная поддержка, версионированная, поддержка query-сета в схемах, авторизация. И что планируется на дальше, это поддержка асинхронных вызовов внутри авторизации, какое-то упрощение работы с повторяющимися объектами с помощью class-based views и какой-то более-менее простой вменяемую поддержку веб-сокетов, чтобы можно было также, не отходя от кассы, создавать какие-то веб-сокеты прямо в этом же Django приложении, не создавая какие-то дополнительные сторонние сервисы. В принципе, все. То есть, если вам понравился этот проект, как бы на данный момент единственную поддержку, которую я бы хотел от вас, это зайдите на страничку в GitHub и поставьте дополнительную звездочку, потому что пока это для меня единственная такая метрика того, как люди этим пользуются. И все. Всем спасибо.
Поки даємо час, щоб ще трішки люди пописали запитання у форму. Поки якщо хтось хоче задати питання вживу, чи куди сказати якесь щось, можете спитати. Я дав permission, щоб розм'ютитись.
Привіт. Як мене чутно?
Хорошо.
Я тут в чатику задавав питання, так що повторю його, що там написано. Тобто валідація по типам, да, по генерації документації, це класно, а як воно взагалі з валідації по значенню? Тобто потрібно якісь окремі там бібліотеки використовувати, чи це є з коробки?
Ну, как бы все, что... То есть внутри вся валидация происходит с помощью pydantic. То есть он в принципе, довольно-таки... Ну, то есть, может, даже немножко не стрик, да, то есть, например, булевые выражения можно передавать, например, как 0, 1, либо y, n, вот такого рода.
Ні, я маю, наприклад, у мене є список яких значень, я, не знаю, там будь-що, там, наприклад, список дозволених імен, наприклад, да, тобто там, типа, наприклад,
ну, то есть, може бути, наприклад,
Вася, Петя, Коля, да, тобто це по типу це стрінг, да, а от іменно, щоб значення Вася, Петя, Коля були, а там, наприклад, якогось Сережу ми не розрішаємо, да, от,
да.
типа...
Да, я понял, в чем вопрос. То есть, в принципе, есть поддержка enumов, да, то есть можно описать какой-то enum, да, и вот оно прямо, это есть частью даже OpenAPI спеки, оно прямо внутри, вот даже Swagger UI покажет даже дроп-даун, да, вот Вася, Петя, Коля, а других значений даже не даст. И в то же время произойдет валидация на бэкэнде того, что переданы именно эти значения. Плюс поверх схем, вот этих pydantic моделей можно делать свои дополнительные валидаторы, да, например, ну, не знаю, нужно проверить, что email у нас присутствует в базе, то есть можно вот написать валидатор, который возьмет вот значение email, пойдет в базу, посмотрит, есть ли оно, и если нет, то вернет валидацию, что вот такого email, например, нет.
Сподіваюсь, Віталік дав відповідь. Я переходжу далі вже до запитань, які були зроблені через форму. Мабуть, це був хтось з нашого чату. Це був Зі. So, I recently switched from Flask to FastAPI. Do you think that using FastAPI in Django will ever be a thing? Because for me, it looked like more a Flask replacement.
Ну, суть в том, что можно, то есть я вообще за то, чтобы миксовать То есть чтобы... Потому что не всегда удобно, да, использовать какие-то библиотеки и как-то их вот этими вот sync-to-async адаптерами потом
Віталік,
обновлять.
якщо можна, тоді я відповідь англійською, бо Карсон
Okay.
він англомовний.
Yeah, so my vision is that it's really uncomfortable to always live in an async world. It's more comfortable to live in like mixed. Yeah, you can write some functions, some operations in sync mode, and some operations are in async. So for example, you use two libraries, like maybe like one is like completely sync, then yeah, you better use like operations in sync mode. And then on the other hand, maybe you have some, I don't know, like maybe like some search engine or like some HTTP calls that are in really in concurrent environment. There will be way more performance to use it in async mode. So then for this type of calls, you create your views in async mode, and it's the mix that will make it your life way perfect, I think.
Thanks. One more question. When you create a method to receive a request in the method as a variable, you pass a request. Why not remove it?
Well, this is done specifically to be more like same way as Django does it. So every Django view have a one required request argument. So I want it to be the same. And on my practice, it's always kind of you always use request actually. Like if you need like a user authentication, maybe some headers. So it's really more of like it's compatibility. Yeah, it's same approach. So you don't really switch between. And on the other hand, like I tried to use it in Fast API where you need specifically provide request as a dependency, and this makes it like your code way more verbose and way more like you have to do like more lines of code to just access the request. So I think at my practice it was like not really comfortable, just easier always to have access to the request.
Nice. Давай далее. Что насчет сложных схем входных данных со списками вложенными объектами? Ну, по-моему, я видел.
Да, то есть там был пример с вложенным объектом. Точно так же можно сделать лист в квадратных скобочках, сложный объект, union, enum. То есть, в принципе, то есть вся вот эта сложная вложенность поддерживается за счет PyIdentic, и он, в принципе, так как он с сайта нам компилируется прямо в бинарный код, он довольно-таки производительно все это парсит и валидирует, то есть и за счет вот этого, то есть вот эти вот тесты на скорость валидации, они, в принципе, работают с вот такими вот сложными вложенными списками объектами, и вот именно вот здесь и происходит так, как бы ускорение раза в 2 быстрее, чем тот же Django Rust Framework.
У мене є питання. Питання наступне. З Select Related і з фокусом Async to Sync там ясно. А з Prefetch Related воно так само спрацює?
Я, честно, не уверен. По-моему, Prefetch Related тоже как бы это все в одном... Ну, то есть там фактически будет 2 SQL,
Ну, залежить від кількості таблиць, може бути 2 і більше, там ж кожна many-to-many або many-to-one колонка, вона окремо йде запитом. Через те й питаю, бо Select Related і просто query set – це один запит, а там може бути декілька.
Да, но вот именно когда вот идет evaluation, то есть вполне может быть, что prefetch related, то есть если конвертируется в лист, он тоже сразу вызовет эти несколько SQL запросов и слепит вот эти вот. Ну, надо попробовать, на самом деле, если сделаю пометку, то есть я на 100% не уверен, но попробую потестировать. Хороший вопрос, спасибо.
Дякую.
Окей. Следующий вопрос. Схемы поддерживают декларативную и кодовую валидацию?
Что такое кодовая?
Я так понимаю, ты можешь описать схему через JSON, да? А можешь описать как-то через объекты, функции и так далее. Грубо говоря, сгенерировать ее с помощью Python-кода.
Ну, в принципе, можно с помощью Python, да, воспользоваться этим type функцией, сгенерировать вот какой-то новый объект. То есть у меня, в принципе, есть в планах еще какую-то автоматическую генерацию схем и, например, из Django моделей, да, то есть взять какую-то модель, сказать, дай мне схему для нее. То есть, ну, в принципе, тогда потеряется вот эта поддержка IDE, да, то есть тогда этот класс как бы не сможет как бы делать автоматическое дополнение. Но в то же время это как бы может упростить работу, да, вот если у нас какие-то толстые модели, и не захочется как бы копировать все эти атрибуты, все эти классы, и тем самым, может, да, мы потеряем поддержку IDE, но как бы упростим себе работу, вот, создавать динамические эти схемы.
Есть, правда, шанс, что я неправильно понял вопрос. Idенtic Fast API на Django. Віталік молодець. Не забувай про документацію, залінкуй доку на Fast API. Так, я абсолютно згоден. Це дуже круто. Тому що Django, воно нікуди не піде, а Fast API достатньо таке щось свіженьке, щось новеньке і цікаве за останні роки. І поєднати їх, це достатньо дуже круто. Так, і останнє, це більш, мабуть, не питання, це рекомендація. Віталік, ніндзя, як правило, асоціюється з темплейтами. Можливо, варто перейменувати.
А с какими? С Джинджа, наверное. Ниндзя и Джинджа или как? Есть какие-то ниндзя-темплейты?
Так, здається, є якісь ніндзя-темплейти, але я не впевнений.
Ну, не знаю, пока вот то, что мне добилось гуглиться, то есть если гуглить Django Ninja, все-таки проект сейчас выходит на первое место, то есть вроде бы нормальное имя. Мне другого нет.
Так. Дякую, мабуть, поки що запитань немає. Є ще час, що хтось хоче, може, запитання задати? Окей. Добре. Тоді дякую тобі, Віталік. Це було надзвичайно цікаво і свіженько. Next speaker will be Carson G. from DataRobot and previously from NASA. Yeah. Yeah.
Cool. Hi. Thanks for having me. Sorry, I only know English. I know like 15 programming languages, but only one spoken. So have to bear with me, I guess, if I get too slangy or anything. So I'm a software engineer at DataRobot. I work on their test automation team. And big reason I started at DataRobot is interested in scaling up. In my career, I've done some interesting stuff, but I've never worked on a like software engineering team that's more than like 15. So working with like hundreds is really interesting to me. So with that, I'm going to talk about like kind of that experience of scaling stuff from working on a small project in a small team to working on a large project. And in this case, specifically looking at a cool PyTest plugin called Testmon, and then how we scaled that up to work for hundreds of developers instead of just you on your terminal. So first, a quick overview. A little bit about me is I did work at NASA. It was super cool. I worked on snow and ice penetrating radars to map out what's under the ice in Antarctica, Greenland, and Mars. And I've also worked on Open edX for doing open education. I worked at MIT there, and worked at an MIT startup and brought an electric bicycle wheel called the Copenhagen wheel to market. It turns your bike into an electric bike. And then worked at a weird fabric nonprofit organization, about 350 million org to make Fabric smart. So I built an AR-enabled social network there, mobile app, where we hacked weaving machines to pump out backpacks that we could recognize with classic computer vision. And then most recently, I've helped DataRobot run 70% less unit tests and integration tests, which is kind of the topic of the talk. So yeah, what is PyTest Testmon? It's open source plugin. It basically records as you test using coverage.py and create signatures of each code block. So down to the function if, just Python indent block level, and creates a dependency map of those. So it starts recording when you run a test and records what you did, and then decides the next time you run those tests whether you should run any of the tests or which tests you should run. So here's kind of the flow diagram for that. The stuff in pink is PyTest Testmon, and like the white stuff's just standard PyTest. So it just uses a bunch of PyTest hooks. So PyTest starts, Testmon determines which files changed based on the last modified date that it stored of all the files in your repo in its SQL database. Then PyTest starts collecting files and asks PyTest Testmon whether it should collect it. So this is kind of a performance optimization step. So Testmon goes and sees for that test module file that PyTest has collected if any of the nodes in the dependency graph have changed. If none of them have, it just tells PyTest not to even bother looking at what test to collect. Then after that phase, it starts collecting the individual tests within the files, and Testmon goes through and analyzes each of those to determine if the dependency blocks changed. And if so, it dumps the tests out so they don't run. And then it starts testing. It starts its coverage trace. The test runs, and Testmon writes that all the lines that changed as signatured blocks to the SQLite database. So basically, this ultimately means, and it's a cool project just to use locally if you have smaller projects, you can just add it and just run PyTest with --testmon. And while you're developing on a feature, it'll just only run the tests that need to run, quote unquote, and allows you to kind of speed up your local development, as well as kind of tells you where the code you're touching. If you're working on the code first and not the tests, you can kind of see what tests you're affecting while you're changing code, which is kind of cool. That said, this is all kind of works great for local small projects, but what about something big like DataRobot? Well, DataRobot's pretty big. Right now it takes 4 days to run the test. That's not including setup time. That's just actually running the tests. And that's because at DataRobot, we have a big fast-moving mono repo. There's over 12 million lines of code. Over about 2 million of them are Python. We have 70,000 PRs and over 100,000 commits. And every master branch merge runs over 150,000 tests, including some duplicates. So we're still migrating from Python 2 to Python 3. But we also run in different environments like Kubernetes and Hadoop. So basically, we need to run tests faster because you really don't want to wait 4 days for your PR to know if it's any good. So there's a bunch of classical strategies that you apply to get rid of the 4 days, right? No one really is going to wait 4 days at DataRobot to merge something. So you start out with parallelization. You start doing it on one machine. But you start to run out of cores, so you start doing more servers. Well, the problem with this level of parallelization and this many tests and this much test run time is as you scale up that parallelization, you start having more likely to have like infrastructure flakes, like hard drive goes bad, network request fails, etc. So you're more likely to have to rerun the whole suite. And the setup time starts to dominate testing time. So if you parallelize so that there's a server for every test, because you have infinite money, you're still going to end up not being able to beat 21 minutes on the clock on your desk, because it takes that long to install dependencies and whatever else, and then it runs the one test. And then also it takes too much money. So we are doing this, but it has some limits, and that's why we might consider something more advanced like testmon. And then additionally, you can start running tests nightly, but there's so much change happening in a given day that tracking down failures is really hard. We do this too at DataRobot a little bit. We run some tests on nightly jobs, but we tend to choose tests that are either slow running or stable, unlikely to break, etc. And then the final strategy you can do to reduce this runtime is just run fewer tests. So some of the ways you can do that is co-location of tests, so or doing hard dependencies between different modules within your mono repo. Some challenges with this is just that it's hard to keep clean dependency graphs when it's so easy to just import from this module 7 folders away without some kind of enforcement. So we're moving towards being able to write some tooling to enforce those sorts of dependencies, but in general, it's challenging. So all that said, we're doing all those things, but we need to optimize even more because I still don't like waiting 2 to 3 hours for my PR to merge or waiting that long to know that my unit test failed. So enter PyTest testmon. Since it's using the smart dependency graph, it just chooses the test to run across all of your test suites based on the changes in your PR, which means less tests equal less runtime, which is great. And then a really cool, weird side effect is that you run less broken tests that are relevant to your PR. So in this large of a mono repo at any given time, there's some percentage of tests that are broken in master. And instead of having to have your PR blow up and fail because somebody in a totally different team breaking the tests, if you didn't make changes in that area of the code base, it won't even run those tests. So you won't even know. So surely this is a great plugin. Let's just use it. What could be so hard about doing this at scale? So here's why it doesn't work at scale. It is designed for local development, as I mentioned before when I was giving the overview. And huge side effect of this is that it requires you to run all the tests to populate the DB. So if you've got 150,000 tests and you need to run that on your laptop as a local developer, you're going to have a bad time. It's going to take, again, there's only so many cores you have on your laptop. And in some cases, there's probably tests that require more memory than you have locally. In addition, so let's say you start distributing it, you have the SQLite problem, which is more or less SQLite is a file that, it's not available over a network call. And it's, well, there's some tricks to get around it, but SQLite is basically a single writer. So you don't even get to use multiple cores if you're writing those dependency graphs to your SQLite DB without some tricks. And the way that the main branch of testmon is written is it doesn't do any of that. So it just fails. And then outside of testmon, if you change like an email template, testmon has no way of knowing that email template changed and will break a bunch of unit tests. So you got to deal with that problem. And then in general, it's just not ready to deal with millions of lines of code. Just performance-wise, it's just not been tuned for that. So how did we get around all this stuff? You can kind of see this orange stuff is the stuff we did at DataRobot to deal with it. So we first split the process of updating the dependency graph database and running the tests into 2 different processes. And so on the update process, we split all into the 50 servers or so to run all our tests. We download the latest version of the database from S3. We run the latest tests with testmon. We artifact those DBs. We then copy all those up into a master job, merge all the DBs, and then upload it to S3. Seems pretty straightforward. And then when you're running the tests, it's a little trickier to change. We do the split across all the servers again. We download the DB from S3 that was generated in the update process. And to get around the single process problem, we actually just run PyTest in collection mode and spit out all the tests that it would have selected using testmon, so that we can then run them in multi-process mode with xdist and compiled into C to get some speed optimizations. Additionally, we wrote another plugin, which I won't really talk about too much, called Stereo, which is a acronym for something, but Stereo is a cool name, I guess, that handles the problem with the templates. So if this email template runs, make sure all these tests runs, or this file changes, run all these tests. Cool, seems easy, like we did it. Go team. Wait, that didn't work at all. So almost none of those steps actually worked, and took a long time and iterations to get across fixing it. But basically, running testmon in update mode, because you're not using the cores, and you're running with coverage.py, which has like a 20% slowdown, you're running 4 times slower. So this means instead of running all the tests in 2 hours in the update process, it's taking 8 hours, which by the time we have an up-to-date DB, it's already 8 hours out of date. And so using that to evaluate which test to change isn't very helpful. And then in addition, the DB is so large because it's got like 30 million dependency edges in it. It is a very large SQLite DB. So that just breaks Jenkins. Doesn't deal with large files coming up from executors very well. And then merging all those giant DBs was taking up more RAM than we had, and pretty much more disk than we had when I switched it to using disk. And it was also taking 20 minutes per DB. So the 8-hour time to run it plus another couple hours meant that we were really only getting updates like twice a day, which means most of the time we were just selecting all the tests. So those are all the problems with the update process. On the run test process, we had to download that giant database, which takes a while. And then running the graph analysis when 700 files have changed in the last 6 hours really quickly runs you out of memory and time. So our unit tests take about 30 minutes to run normally, and it was taking 45 minutes for testmon to decide what unit test to run. So not so good. And then we also had a fun bug where because we have this split process of collection and running of the tests, if you had a randomized parameter in your parameterized test, it would select one random string here, go to run it, and it would not find it here and not run it. So tests that we knew we should run weren't necessarily running. So each one of those became challenges that took several months to kind of work through. And the way we fixed it was by forking. To start, you can check that out. In addition to that, we also scaled up the server count. So we're running twice as many servers to get rid of that extra 8 hours, in addition to a lot of DB and schema changes, reduced, another, like cut the time in half again in the recording and storage process. And then some of the craziest code performance code I've ever written before, where it turns out fingerprinting these code blocks to build the dependency graph, you start to care about little things like regex being slower than doing a white space strip on a line to determine whether a line is blank or has a comment in it to create your fingerprint. And then additionally, the plugin as it stands sorts all the tests so that the fastest tests run first. I don't actually know why that author chose that choice, but that was taking us 5 minutes because sorting 34,000 tests takes a long time. And then if you want to check out a crazy PR where we just did tons of memory optimizations, unraveling loops, and getting rid of some functional code that wasn't releasing memory, I have a PR that's linked in that slide that shows kind of all the crazy stuff we did. And yeah, so after several more months of development and optimized tuning down to choosing to find blank lines 35% faster, we finally got it so that we're selecting tests within 5 minutes, and the updates are taking about an hour and a half as opposed to 10 hours. And so we're effectively have scaled it. And so after all of that, you really had to do all of this work, months and months, just to even figure out whether it was worth running. So was it worth it? Did we actually save money or time or effort? Here's kind of the visual that makes it for me. So this is right off of our Jenkins page from before we turned on Testmon. And here you can see we have about, this is just for one of our test jobs. We split our unit tests and our integration tests. This is just the unit test job. So we have about 29,000 unit tests. And we were just running them all for each one of these is probably a PR, or at least a commit on a PR. We're just running them all the time. Well, after Testmon, what does this look like? Hey, so you can see that we're dramatically running way fewer or less tests almost all the time. The average bar here ends around, it's about 6,000 to 7,000 tests per run as opposed to 30,000. And you know, there's a ton of variance, of course. We have rules that if you change a dependency, just run all the tests. So you'll see like a PR that's changing a dependency gets stuck into this running all the tests. But in general, we're running way fewer tests. And that's great, assuming that you're running the right tests, right? So it's not all peaches and cream. It's not all great. So, but I think it's probably still worth it. We run about 70% less jobs or tests on the jobs that we're running it on. The runtime's only down about 30%, unfortunately, because so much of our runtime is setup time. But we're still saving $600 a day. And maybe the not so great about it is that our master branch breaks all the time. So that's maybe the only real caveat to this. We fortunately day robot have systems to make this pretty manageable, but in general, it's, you know, so far the most we've ever seen is 7 times that it's broken master in a week, but usually it's 1 or 2 times a week, and in general worth it. I mean, assuming that this can run for a long time, all those months of work we spent scaling it up and performance optimizing it should hopefully pay off in actual dollars and cents within some period of time. So yeah, that. And then, so we're not done, of course, there's always more work to be done. Some of the stuff I want to do going forward is automating the corrections to those failures in master. So one of the cool things you can do is if a PR doesn't run a test that breaks, and then it breaks on master where we run all the tests, you can potentially automate the discovery of the failure of that dependency graph and add an automatic rule so that that decision doesn't fail again. And then there's still drift. If you kind of look back at this graph, you'll see cycles of time where more tests are selected. And a lot of that is because the database isn't updating as frequently as we would like. And then right now, when we're scheduling all those servers, we're not taking Testmon into account beforehand. So occasionally we'll fan out to say 20 servers to run the tests, and one won't run any tests and one will run all of the tests. And so you'll have some that finish in 10 minutes and some that finish in an hour and a half. And so if we use the graph before we scheduled, we can even that out, hopefully. And then the big kind of scary problem that I haven't figured out how to resolve is that there's some caching issues with CoveragePy/Python itself that I haven't really sorted out. So if you have 2 tests, A and B, and they have basically the same dependency graph, because they're testing the same module. Test A in the SQLite database and in the coverage py trace that we have, we'll have all of them, all of the dependency links, and B will have some smaller subset of them. And I think it's some caching going on with module imports or something. And if you flip them around, B will have the full dependency graph and A won't. So that's the source of a lot of our master breaks. And yeah, that's PyTest test. Any questions?
Yeah, thank you. This was really interesting. 25,000 of tests. It's huge.
Yeah.
Crazy.
Yeah, and that's just our unit tests. Our integration tests that use DB and task queues and stuff. It's 35,000.
I give permission to unmute yourself, so feel free to ask your questions, and we were waiting for questions in our forum. Anybody? I bet nobody writing tests at all.
I mean, the real solution is, yeah, just don't have tests. What do they even do anyway?
Okay, maybe I will ask a couple questions. So I've already placed them in Google Docs. So Sergey, I will try to recall what I've placed there. So first question. So you were hi, my name is Igor. My name is Igor. I will be speaking just after you. But question: you were referring to graphs of tests and that you constantly check what was changed in that graph, etc. But you are using SQL database. Have you ever considered using a proper graph database for such, for finding complete traverse of dependencies?
Yeah, that's a great idea. Doing a join on 11 million rows is not super fun. So we have talked about it a lot. One of the things that comes up short, and don't have a lot of experience with graph database, so I'm open to suggestions, but because we're writing so much data and it needs to be so quick, SQLite is really great for when we're writing. It's not so great when we're querying, but it's pretty quick for writing the dependency graphs. And so one of the reasons I haven't yet explored using a different DB is because of that. But if there's fast, local, exportable graph DBs, I'm all ears.
Okay. Thanks for answer. And second question from my side, that I've checked PyTest Tesmon codebase, and I've seen that you configured SQLite very efficiently, with different configurations like auto vacuum, cache size, etc. But have you tried using SQLite write-ahead log mode or not? And if not, if you've used it, so have you noticed any difference?
Sorry, with which option?
Write-ahead log file. So it has val log writing mode, etc.
No, I haven't tried that. I'll write that down.
Yeah, I agree with that. We have a different place in DataRobot where we leveraged the wall mode for SQLite for writing some local data, and it was quite a dramatic improvement. It loses some consistency, meaning if there was a write going on and suddenly down, you lost power, you won't get that record, but you don't lose durability. So your database will still remain in a valid state.
Yeah.
And by the way, regarding graph databases, it could be worth looking into cloud solution, which is already provided by AWS. They presented their own Neptune graph database a couple of years ago, and I think you would at least get rid of potentially some performance bottlenecks, since you would have a cloud version of that same thing. like centralized.
Cool. Yeah, that's awesome. I thought I had read every SQLite, Pragma, and option ever. So it's great to hear there's others.
Cool. Okay, no more questions from my side.
I will read some questions from the forum. Can you show how it works? This is the question.
Sure, I guess. Yeah, hold on. I was just running a memory profile on it. So let me pull that up. Yeah, so here is the latest in me running memory optimization profiling after trying out some stuff. So more or less, so here's that no sort option that we added. And then by default, Testmon kind of cowardly refuses to select tests that have marks on them. I don't really know why. But
sorry, but we still see the slides.
Oh, nope. Oh. Gotcha.
That's fine.
Oh man, it just really likes sharing that one. Cool. Let's just see if we can. There. How's that?
Yeah, good.
Cool. Yeah, I'm not going to run the test because again, 28,000 tests, but I can show. So this is just running it. I'll run it with the memory profiler. So this is saying don't run the dependency graph. So this is kind of the test running side of things. So don't update the DB as you go because it slows things down. Don't sort the test. That's that option that we added that was taking 5 minutes to sort 30,000 tests by time. And then for select is Testmon kind of cowardly refuses to accept marks. So this tells it to allow marks, PyTest marks. And then I'll just collect and I'll put it in verbose mode, which should have some kind of show some stuff. Exciting.
Yeah, it's warming up, so we have more questions.
Sure.
The question is, so many tests, how helpful they are? Can't we just throw away some of them?
Yeah, I mean, so my kind of, after this project wraps up, my next big idea, quote unquote, is kind of a dynamics test selection based on stability. So basically, I want to write a PyTest plugin that makes an API call to ask which 10 tests haven't failed in the last N amount of time and just not run those. So they just are excluded from selection with the concept that no one really has time to comb through and audit all their tests. But people do have, but you know, we can use that tracking data. So then, like, you worked on this feature for a while, you wrote a bunch of tests, and then you stop working on that code for maybe months, maybe weeks, maybe days, who knows? And so we can just be like, hey, this test has been stable and hasn't failed in a week. just stop running it all together, and then have kind of a process that runs on that nightly queue or that weekly queue that tests all those tests that we stopped running, just to make sure that they haven't started failing. And as soon as they start failing, start running them on everybody's changes. But if you have other ideas on how to reduce the number of tests, that would be great. But here you can kind of see Testmon skipped 2,000 files and found, since this database was last written, it found 535 files. And then it lists all the files that have changed. And then instead of selecting 28,000 tests, well, it died somewhere in collection. So it's not the best example, but yeah, it will deselect, you know, something like 23,000 tests normally.
Yeah, it looks like PyTest.
Yeah, yeah. Definitely.
Yeah. One more question. As I understand, you forked your version from original. Do you plan to make a pull request back, or you will develop your own version separately?
So I would definitely like to contribute back. I opened a PR with just a really simple bug fix, just to kind of see the maintainer was willing to take our code, and it's been open for months without any response. So it kind of feels like they're not maybe interested in getting our contributions, and they hadn't worked on it for 5 or 6 months. Although last week he added 3 more commits, just kind of out of the blue. So basically, I haven't been able to figure that out yet, but I would love to, and have been given permission to, and all that, and would be happy to like contribute these up. I would much rather have that than maintain our own fork and push out packages or anything.
Yeah, open source is the thing. Yeah.
Yeah.
Some projects are quite active developing and create contribution and community around this, but sometimes you really don't have time on this. And
yeah, no, I mean, even I'm the worst. I have the PyTest PyLint plugin that's open source that's in the LvivPy, and like sometimes I just can't work on it for several weeks and like feel bad, but yeah. Open source
and
life.
one more question from the forum. Isn't the right time to split the monorepo?
Yeah. I don't know. There's lots of advantages to the monorepo, right? It simplifies CI/CD processes when you're deploying huge clusters. Ideally, you can keep, I don't know, it's just a fine line to walk, and it's really hard to move once it's become this large. Like, how do you start slicing out 16 million lines of code or whatever?
That's a topic for another report, I think. Maybe
Gotcha.
more than one.
Yeah.
But we are rather fans of monorepo than not. So there are some cool advantages to that.
Yeah, I mean, honestly, a lot of the stuff that we can build is based on having this monorepo. Like, we're getting some advantages by having a single repo to move. Like, we don't have to duplicate code and have different edge cases and whatever else.
Yeah, it obviously depends on the project and the team. Because, for example, currently on our project, we have lots of issues with monorepo. Usually it's related to release dates when we have to roll out everything in one go.
Yeah, in our case, because we also do use monorepo, like on big scale, problem not even in releases, but in processes and discipline from developer side. I mean, that's a big problem, but I do like monorepos.
We resolve major issues with release stuff by having feature flags, and essentially we are not scared, and we educate people to not be scared that master should and is safe to have your changes as long as they are hidden, as long as you know how to and when to turn off things or turn things on production and whatever. So we educate that it's safe to have repo and the master should be safe. It's your responsibility to bring your feature and make sure that it's not breaking anything. So feature flags to go.
Okay.
Okay. Thank you, Carson. Yeah.
Yep. Thank you.
Next speaker will be Igor. He will also present in English. So, yeah. Stay tuned. You're muted, Igor.
Yeah, I'm always confused with this Zoom UI, like especially when you start presenting something. So where is this mic icon? I don't know. Okay, you already seen half of my presentation. Okay, cool. My presentation is called Developing Own Jupyter Cloud. But let's start from introduction. So do my, yeah, here's me. Now you can see me, I hope. So my name is Igor. I'm data engineer. I'm working at currently at Amsterdam, a big fintech company which called Adyen. And mostly I was last 2 years working with building a data science platform for analytics, for running machine learning models, for training models, etc. So for various purposes. Basically, we wanted to build data robot, Databricks, Google Colab in-house here. And one of my main projects, it was building this platform. Yeah. And as you already seen, spoiler, too long, don't read, just use containers or any other providers, because I wanted to tell you that that's just story about data engineer suffering with open source tools, with monorepos, with different processes, and like small notice, no open source tool were harmed during the process. Yeah, we just tried to contribute and to give back, but sometimes we wanted to just to destroy more open source tool. So let's start with the description. What is Jupyter? Jupyter is a web UI for running some session and some session with various programming languages on your laptop or on your environment. And basically, the main feature of this web UI is that it's interactive one. So everything what you can do inside of such such web UI will be sent to that session, will be processed, and will be returned back, and you will see fine output, whatever. And due to weird and obvious reasons for me, this web UI started to be de facto standard of data science community, because they can easily manipulate with the code, they can manipulate with environment, etc. Yeah, and basically it's de facto standard for doing data science. Weirdly, but yeah, it is. If you have no questions or I'm not speaking too fast because I have this feature, speaking too fast, especially when presenting, I can move further. So let's start with the beginning. It's from what this project began, and the small notice. This presentation will be about architectural journey and the result which we achieved, but not about Python side almost at all. So yes. So at the beginning, company started with Postgres, and Postgres was everywhere. Basically, that company was Java and Postgres shop. Everything was in huge monorepo with Java code. If I recall correctly, it was more than a couple gigs of code and jars. basically huge. When I was checking out the codebase, I need to spend, I guess, 1 hour just waiting. And the problem with SQL, especially when you're doing when you do some analytics, that you just drink, wait, or whatever you're doing when you launch very big creepy join. Basically, it was the phrase, I'm just waiting until join finishes, etc. And what company decided to do a couple of years ago, slightly like a couple months before I joined, this company decided to start using Apache Spark. Because why? Because it's hot, because it's so awesome, you can do everything with Apache Spark. Yeah, everything was true with Apache Spark, especially because it has the Python API, PySpark, and data scientists can play with the API, but company made huge mistake. Wrong decision. They started with implementing POC. And the problem with POC is that when you start implementing POC and you show this to stakeholders will test it, will like it, and they will start using it on production. So let's move. So it was one single node because it's POC, and it was HDFS or NFS. So you already can imagine what the problem was there, because HDFS or NFS, so you needed huge network bandwidth, but also problem was in that it was just single Spark node and a lot of users. And as a result of POC, this was Spark node with in-house build solutions. And when I'm saying in-house build solutions, I can say that it was multiple, like, I don't know, even own ETL orchestrator, own build in-house fork to Jupyter, like with changes, etc. So at that point of time, it was good, but as a result, it ended up with a couple nodes with Spark, with in-house solutions, and with the huge problem of maintenance. Because if you were implementing POC, so you do recall that you end up with a number of different bash scripts, etc., with different documentation, which place everywhere, but not in correct place. So maintenance was a mess. Security was very happy with such, like, happy air quotes with such maintenance, and also with the security had its own their own requirements for such stuff and reproducibility. So it was very hard to reproduce with expected results some deployment, rollouts, releases, etc. So yeah, so that's why it was made the decision to change, to change and to build our own Jupyter Cloud. So, and I don't remember why I placed it here, but yeah, the user journey. So we had one big requirement from stakeholders that the user journey should remain the same. So basically, you can see happy user, you can see Jupyter Hub UI, which spawns somewhere, and which is basically I don't know, umbrella above some nodes, and you can see that users used to work with storage, which is Parquet, Avro files, etc. So, and also, like, that was a requirement from to keep user journey with all the blows and whistles, which I have, and also a lot of another security and infrastructure requirements. Let's dive into what is Jupyter Hub, because I've explained here, and it's one of the main components. So yeah, it's very nice icon, and as you can see, and I've took it from Jupyter Hub doc official. So basically, Jupyter Hub, that's web server, which has which works also with some database. For us, it's SQLite and Postgres. And basically, it's this web server writes to the database what users are affiliated with what servers. Basically, it spawns for every user separate Jupyter notebook server. And basically it saves all the information into some database. Yeah, very simple tool, but very powerful tool because it can enable a lot of features. For example, authentication, not authorization, but it can enable authentication, small authorization because it has small admin interface, but this admin interface end up with stop user server, start user server, etc. Yeah, it has some configuration file enabled, but the main and very important part of the Jupyter Hive is spawner. Basically, tools which can spawn Jupyter single user servers for every user with some additional features. And spawner, there are multiple of them. You can see on this wiki page a list of spawners. Oh, yeah, it's a list of spawners, but the most popular of those spawners is Docker spawner. Yeah, so to spawn everything inside of Docker container. The sudo spawner, batch spawner. Yeah, sudo spawner is very nice tool, but I will speak about it a bit later. Batch spawner was never using, and my favorite spawner is a CR spawner because we end up with that one too. Also, systemd spawner. Systemd spawner that basically spawner which works with containers on lower levels than Docker spawner. So basically, it also works with the native LXC containers with isolation, etc., but on more lower level. So first we tried sudo spawner, but security wasn't happy because why? Because it's called sudo spawner. Basically, main process needs to be run like a sudo, like with the sudo privilege, like sudo privileges, and basically after that it does simple commands sudo -ash. Basically preserve environment -u and etc. 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 And the biggest problem here is that main process is run like a sudo user. So basically, if there will be some ingestion or some attack on the Jupyter Hub, user can get full access to the system. So yeah, so it was nice experiment, but it finished very fast. Then we've tried to work with systemd spawner. Systemd spawner, that's tool, as I explained, which works with systemd with LXC container. So basically, it does command like chroot, etc. And it works as a charm because no need of sudo user. You can spawn multiple servers, etc. But problem was that it works on one single machine, and all your Spark jobs, if you need to spawn like a PySpark processes, etc., will be spawned in local mode. And basically, that means that you don't have full control of the resources for which are dedicated to that single user server, and you, especially for Python side, because Python side will be shared, and you will be controlling just number of executors, number of resources per executor, which will be running on different machine, remote machines, and also that leads us to imbalance in HDFS because of local mode, and driver will be submitted on local mode. And that's why we started to look for another solution, and we made wrong decision again. Like let's rebuild everything from scratch, basically. Yeah. For now, because I just finished this project, I can say that it's wrong decision because I'm tired because of that, but maybe it was a nice decision. So, and a couple of months later, we've ended up first we built it. Yeah, it's not perfectly centered. Sorry for that. But after a couple of months, we've ended up with some cluster. It's very usual one. So basically, you have like HDFS cluster with high availability tunes. So basically, you have name nodes, you have journal nodes, which working together to maintain availability for writing on the HDFS. And we have multiple data nodes, so number of them was big one. And all the activity, like all the job submission, etc., we've used a simple approach to submit from edge nodes, basically to place on some of the edge nodes Jupyter Hub instance and to submit all the jobs from there, that stuff. Yeah. Let's dive into components and security and how we were doing it. So as I mentioned, so one of the components like Jupyter Hub was placed here on edge nodes. Which one doesn't matter because how we are communicating. So let's imagine how Jupyter Hub was submitting jobs to the was spawning containers or submitting PySpark jobs, even with the system despawner. So let's abstract and let's consider that Jupyter Hub was running on single machine with system despawner, and on that process, at that moment when it was spawning single user server, it was on the same machine here, and after that single user server like user in user space was submitting jobs to the Yarn Spark jobs, and Yarn was afterwards communicating with the different components, and if there was resources on some machines here on workers, that job would have landed somewhere there. So we thought, okay, if we already working with the Yarn and submitting Spark jobs through Yarn, maybe we can reuse, here was Yarn spawner, maybe we can reuse Yarn spawner and submit even single user servers through Yarn to some worker machine and to offload Jupyter Hub machine. Yeah, so we did it, and we faced very nice results and very big problems afterwards. I will tell you about that, and why. Here's a question, Sergey, or maybe do I need to explain all this flow? Yeah, I guess I need to explain. Sorry, guys. Yeah. So, and let's dive into all the components and how they were working together and maintaining all the flow. So, and let's go through the user flow. So, user were logging if user want to log to the Jupyter Hub was doing LDAP request with it was authenticating. And afterwards, Jupyter Hub was communicating with Kerberos with information about with information from LDAP about user, who is it, in what group it belongs, and what it can do, etc. And if Kerberos has assigned ticket for that user, Jupyter Hub after that could have submit some jobs to the Yarn, which also was communicating with Kerberos about permissions and about what user can do on cluster. Yeah, so we decided if we can do this for jobs themselves, like for PySpark jobs, etc. So let's integrate single user servers with all the environment, because Yarn containers, it's the same LXC containers, but with better isolation, with better resource control than we had with system despawner, and let's integrate even single user server into the Yarn container. And as a result, we found a very nice tool which called Sky. That's print screen from that page. It was written by a very nice guy, Jim Christ. He was working at Continuum Incorporated. That's a company behind Anaconda, etc. And yeah, and why it's Kane? Because it's basically he was playing with word Yarn. And what Skein does, Skein is trying to not train. Skein is trying not to build and provide API for Python process to be submitted to Yarn. Skein tries to encapsulate the process inside of container and to submit that container to Yarn. So if you want, you can go to Skein webpage and to check. It's a very awesome tool, but it's almost not maintained because Jim has no time for maintenance of this stuff. But with this Skein was written a lot of tools, a lot of nice tools. So first it was Yarn spawner for Jupyter Hub. Second great tool, which still in development and in usage, that's Dask Yarn. Basically, a possibility for Dask being submitted to Yarn cluster, and also another company. I always forget the name of this French provider. They brought TensorFlow over Yarn with this. With Skein. So basically we decided, let's integrate Skein, and we were already using, we were submitting single user servers with the inside of Yarn Skein containers, but as you can see, Skein is very bad in communication with Kerberos. So basically we could have submit jobs with we could have submitted single user servers and jobs inside of Skein to Yarn, but as a result, we could not work with the data which was stored in workers. Very, very nice tool, like open source. After that, we were trying to submit some pull requests, but as I told, Jim Chris has no time for the tool. At the time, we decided to go even deeper. We decided to abandon Skein and start using Enterprise Gateway. That's another tool from Jupyter ecosystem. I even have a screen from their official documentation. So basically, Enterprise Gateway, that's next step in evolution of kernel gateway. It's standalone web service. It can be placed somewhere in your cluster, and basically your single user server or your Jupyter Hub service, etc., will be communicating through the HTTP or WebSocket services. Some calls will be done with HTTP, some calls through WebSocket. We'll be communicating with Enterprise Gateway, and Enterprise Gateway with knowledge about some cluster, like with some knowledge, will be submitting jobs to different nodes, and we'll be communicating with them through a ZeroMQ protocol. So it was a very nice idea, and we did it. We created such integration. It worked as a charm, but in a couple of days, we've noticed next picture. So here you can see 500 GB of RAM, and basically in one day, all RAM was filled. So why it happened? Why it happened? Because when Jupyter Hub was submitting through Enterprise Gateway notebooks to workers, Enterprise Gateway was constantly asking state of that notebooks through cluster. Notebooks were constantly updating Enterprise Gateway with their own state, and basically one instance of Enterprise Gateway was DDoSed by multiple workers and multiple notebooks. Just for example, one notebook was producing around 2K of requests per second when it was losing connection, and it was basically no go for us because with such RAM usage pattern, you could not have so much RAM to fulfill the needs, like 500 GB of RAM. Guys, come on. And the next evolution in our development, it was to place enterprise gateway instance and in every worker. So basically, every dedicated notebook and single user server was communicating with dedicated enterprise gateway instance inside of worker. At this moment, we have decreased the number of requests for enterprise gateway, and we some kind of achieved that what we wanted to achieve. So basically, in component view, for user, nothing changed. As I've showed before, user was working with Jupyter Hub and submitting different and working with the data stored somewhere in per K hour or the databases, but in components way, it started to be much more complicated. We could have get LDAP, LDAP authentication, authorizations through Kerberos, restrictions, like basically what user can do, what data user can read, etc. And also we could have get guarantee of resources and resource management. And the very nicest part that we can scale a lot, like hardware scale, like adding just nodes, and Yarn will find out and will know what it can do with nodes. Yeah, that's what I wanted to tell. Yeah, that's all. I was speaking very fast, I guess. Do you have questions?
I see no questions actually in forum. I will give a permission to unmute. Yeah, so feel free to ask your question by voice.
As always.
Yeah.
As always, I came here, I told some strange stuff, and no one like, what? What are you speaking about?
Kostolechenko, I wanted to ask you a question. How do you like the Jupyter Hub? Because we were trying to set up it as well, and we had a lot of problems when trying to configure it.
Write me in private, but first, but yeah, Jupyter Hub is a kind of good tool because it's raw material and you can build everything what you want and what you need from the tool. But the amount of headache which you can get from basically one configuration is enormous. I would say if I have choice, like of what to do, so I would go with Jupyter Hub, but with different spawner. I mean, like Docker spawner, Kubernetes spawner, etc., where you can more granularly control resources and the job submission. Because in our case, we were forced to, like, because the company total on-prem and the company is against containers, we were forced to use a different approach. Like as you've seen our journey from sudo, systemd, and finally yarn spawner. So I would say it's very nice tool, but you need to be very careful in configuration and what to use from the tool.
Thank you.
Okay, no questions.
No more questions. Okay, looks like that's all. No lighting talks for today because the registration list empty. So yeah, Igor, thank you for your talk and presentation. Yeah, please share your slides to the chat or directly to me in Telegram or here.
Yeah.
The chat will be saved. And that's all for today. Thank you all. Bye.
Thank you.
Thanks.
Thank you.